today we're going to talk about scientific notation. Before we begin, I want us to look at a couple of things. Let's look at these abbreviations and let's talk about what they mean. So LOL means laugh out loud, whereas JK means just kidding. Here's a couple more. And UGTBK, I actually did not know what is too good to be true. You've got and then this one here, this one is actually around way before text speak came along. This ASAP or ASAP means as soon as possible. Alright, so just like we had abbreviations for those phrases, the whole point of abbreviations is that we don't have to write as much. Well, the same thing can be said of math. For example, if we wanted to estimate the number of atoms a human body has, it's 154 pounds, that's a really big number. That's a lot of atoms. Or if we wanted to calculate the mass of an electron, that's a really, really, really tiny number. And look how much space that takes up to write those numbers. So what we want is we want to be able to abbreviate those numbers, and we can do so using scientific notation. So scientific notation is just a number that is expressed in the form of A, so A is going to be a number, times 10 to a power. And this A needs to be in between 1 and 10. So it can't be less than 1 and it can't be more than 10 if you want to write it in scientific notation. So let's begin with this number here. If we wanted to write this in scientific notation, our A value needs to be less than 10. So what we'll do is we'll move our decimal over until we get a number that is less than 10. So if we move it this many times, we get 4.200000. So that is less than 10. And since we had to move the decimal point 6 places to the left, we will write 4.2 times 10 to the 6, which makes sense because if you're multiplying by 10 to the 6, your number should be getting bigger. So if I were to multiply 10 to the 6, then my number would be getting bigger, which makes sense because my number was big to begin with. Right, let's try another one. Let's try 0.000067. So this time I have to move my decimal over until I get 6.7. And so since I had to move it 5 points to the right, that means we have 6.7 times 10 to the negative 5. And the reason why is because I want this number, 6.7, when I multiply it, I want to multiply it so that way it gets smaller, right? Because my original number was small. All right, so if you're moving your decimal to the left, you're going to multiply by 10 to a positive number. If you're moving your decimal to the right, you're going to multiply by 10 to a negative number. Let's do some examples. So let's write this in scientific notation. So we have to move our decimal point 4 places to the left, which means that it's going to be 2.95 times 10 to the 4th. Now let's write this one in scientific notation. So we had to move our decimal all the way until we get 4.3, and that was 8 times to the right. So that means we have 4.3 times 10 to the negative 8. All right, so now let's go with something that is in scientific notation and go back to standard form. So to go back to standard form, we just carry out what the scientific notation tells us, or the abbreviation tells us. So 2.1 times 10 to the 5th says to move our decimal 5 times to the right to make it bigger. So we get 210,000. Now this one, 6.8 times 10 to the negative 6. So that means that our number should get small, so we're going to move it to the left 6 times. So we get 0.000068. So notice that there are not 6 zeros here, right? Because this was 1 and then 5 more times, so we have 5 zeros after the decimal. Make sure that when you're writing your work that you actually have 0 and then the decimal and then the zeros, because if not, you could get confused and forget a decimal. Alright, so products, powers, and quotients, which we have learned so far, all of those can be calculated in scientific notation. So whenever we do our products, powers, and quotients, make sure that your ending result or your final answer, make sure that it's still in scientific notation, because sometimes we get a number and we multiply it and then we end up something that's not in scientific notation, and so then we have to change it again. All right, let's do an example. We have 7.5 times 10 to the negative fifth times 2 times 10 to the third. So since this is all multiply, I can use the commutative property and the associative property to rearrange my groupings, right? So now I have 7.5 times 2, and then 10 to the negative fifth times 10 to the third. Now 7.5 times 2, that's just 15. And then 10 to the fifth times 10 to the third, this right here is using my product property, which says that if my bases are the same, I subtract my exponents. So negative 5, not subtract, I'm sorry, add. I add my exponents. So negative 5 plus 3, which is negative 2. So I get 15 times 10 to the negative 2. But wait, we're not quite done. This is not in scientific notation because 15 is not between 1 and 10. So if I want to change this to scientific notation, I need to go left 1. So remember, when you're going left 1, that means that you have to, that would be 1.5 times 10 to the first. Okay, so if it was 1.5 times 10 to the first, now I need to simplify again, right? I need to use the associative property to say 10 to the first times 10 to the negative 2. And then 10 to the first times 10 to the negative 2 is 10 to the negative 1. And so now I have my final answer. Let's do another example. So 1.2 times 10 to the negative fourth, all to the second power. So this is a power of a product, right? Because I have a product inside my parentheses, but then I have a power. So I need to go ahead and distribute that power. So I get 1.2 to the second, and then I get 10 to the negative fourth to the second. And then I have a power to a power. So remember, when you have a power to a power, you multiply. So that becomes 10 to the negative 8, because negative 4 times 2 is negative 8. And then 1.2 squared is 1.44. So here's my final answer. Next example, we have 2.4 times 10 to the 7th divided by 6 times 10 to the second. So remember, division can be rewritten as a fraction. And then now we can go ahead and simplify the 2.4 and the 6. And then we can also have the 10 to the 7th over 10 to the second. So remember, this is our quotient property, which says that if the bases are the same, we subtract our exponents. So 2.4 divided by 6 is 0.4. And then 7 minus 2 is 5. So we have 0.4 times 10 to the 5th. But wait, we're not quite done, because 0.4 is not in between 1 and 10, so that means we have to rewrite it. So I need to move my decimal over to the right, which means that I have 4 times 10 to the negative 1. So now I use my associative property to put these two together. So I have 10 to the negative 1 times 10 to the 5th. So negative 1 plus 5 is 4. So I have 4 times 10 to the 4th as my final. Okay, so we talked about multiplying and we talked about dividing, scientific notation. But before we add or subtract numbers that are in scientific notation, we just have to make sure that both of our numbers are expressed using the same powers of 10. So if we have 10 to the 5th, our other 10 to a power needs to be 10 to the 5th as well. So let's look at an example. So 2.3 times 10 to the 6th plus 5 times 10 to the 6th. So they're both expressed of 10 to the 6th. So the powers of 10 are the same, which means that we can go ahead and add the 2.3 and the 5 together. So 2.3 plus 5 is 7.3. So we have 7.3 times 10 to the 6th. All right, let's do another example. So we have 5.4 times 10 to the 5th minus 4.7 times 10 to the 4th. So this is an issue because the powers of our 10 are not the same. One is the power of 5 and one is the power of 4. So what we need to do is we need to change them to be the same, okay? So it's always kind of neat to go up. So what we'll do is we'll take this 10 to the 4th, and let's say I want this to be 10 to the 5th instead. So if I want to be that 10 to the 5th, that means I had to, I want this to be the same, right? So right now it's 10 to the 4th, and if I do 10 to the 5th, then this means that this number went up, which means this number needs to go down, so it needs to move over to the left. So I have 0.47 times 10 to the 5th. So again, to move 10 to the 4th to 10 to the 5th, that means I had to increase this number, which means that this number needed to decrease by 1 decimal. So that means it went from 4.7 to 0.47. Now that the powers of 10 are the same, I can add, or actually we're subtracting the numbers, right? So 5.4 minus 4.7 gives us 4.93, and then we have times 10 to the 5th. Alright, so in word problems, or when you're using scientific notation, a lot of times the numbers, instead of writing these really, really big numbers, they will just write the prefix, okay? So, and the prefix tells you the value. So, tera means trillion, giga means billion, mega means million, kilo means 1,000, and then we have our really, really small numbers have these prefixes. Milli means thousandth, and then micro means millionth, and nano means billionth. And then these are the powers that go along with those prefixes. Alright, so let's look at example 5, which if you want, you can actually read in your textbook on example 5 on section 8.3, and it will tell you like the word problem that's going with it, but basically we're trying to look for the difference, like how much more something is. So what we're doing is, first of all, we have to get our bases the same. They both need to be the 24th power. So we have to change 6 times 10 to the 23rd, and we have to get that to the 24th, right? So that means if this one goes up, this one needs to go down. So this will change to 10 to the 24th, which means that this needs to change from 6 to 0.6. And now that we're the same, we can find the difference, right? So we have 6 times 10 to the 24th minus the 0.6 times 10 to the 24th, which is what we just calculated. And then we got our answer. So now that we know that, Earth is about 5.4 times 10 to the 24th kilograms more massive than Mars. Alright, next example. So we want to divide these two numbers, but to divide those two numbers, they have to have the same powers, right? Oh, actually, no, we don't have to have the same powers for this one because we're dividing. We only have to have the same powers if we're adding or subtracting. So this one, we can just rewrite as a fraction and then use our quotient rules. So 2 over 6 becomes 1 over 3rd, and then 10 to the 27th over 10 to the 24th becomes 10 to the 3rd. So 1/3 is 0.3 repeating, right? And then times 10 to the 3rd. But this is not quite in scientific notation. We need to move over to the right one, which means that we're subtracting. When we rewrite it, 0.3, if we move it over 1, that means that we're moving to the right, which means it's negative. So 3 times 10 to the negative 1, which means that we can now use our associative property and combine 10 to the negative 1 times 10 to the 3. So negative 1 plus 3 is 2. So now we have 3 seconds. And then, so 3 times 10 to the second is about 300, is 300. And so what we calculated is that Jupiter is about 300 times more massive than Earth, if you were looking at the problem in example 5. All right, go ahead and try some problems on your own.